Okay, we're going to find the central angle in radians given the radius and the arc length. So we're going to find this angle given the radius and the arc length. Well, there are only three variables here. There's this is not a variable. This is the whole circle. It's either 2 pi or 360. Pi is not a variable, so we just have r, s, and theta. There's only one thing that we don't know is theta, given everything else. So all we have to do is a plug-in. So if you know this relationship, it's all a plug-in. So we start with putting 15 in for s and 10 for r, and we don't know theta, and we just cross multiply basically, right? And find theta. So first, let's just go ahead and reduce. Okay, and did you know that you can reduce this way? Yeah, you can. Okay, you can reduce up and down, across. Just do not reduce diagonally across the equal sign. You reduce diagonally if this is a multiplication, but these are on opposite sides of the equal sign. So you're going to have to, instead of reducing diagonally, you're going to reduce across. You can reduce this way, this way, this way, this way, right? Things like this is like a fraction, and we can always reduce this way, right? As one fraction, we can reduce the 15 and the 10. And because this is on the opposite side of the equal sign, we can reduce across this way. Okay, we reduce the 15 and the 10, we get a 3 and a 2. So theta is equal to 3 over 2 radians. This is not too bad, right? We usually have a hard time with this normally in class, and on the test people get this all mixed up. If you have the formula, it's all a plug-in. And if you don't like to reduce, just crank it all out on your calculator. Do the 15 divided by 10 divided by 2 pi, multiply by 2 pi, and you should still get 3 over 2 radians. All right. Let's try another one. Here's my formula. Here's my arc length. Here's my radius. This is find the angle in radians given the radius and the arc length. So we're going to put in these 7 and 11 into s and r and solve for theta. So the 2 pi's cancel, and then we just have theta is equal to 11 over 7 radians. Okay, find the arc length given the radius and the central angle. Now we're given the angle and we're given the radius, but I don't have the arc length, this piece here of the circle. So I'm going to put the numbers in here. Now, because we're given degrees, I use the degrees this time instead of the radians. The units have to cancel. I have to have degrees to cancel the degrees, otherwise this whole thing doesn't work. So we use 105 degrees over 360 degrees, so we can cancel the degrees, and r is 5. So multiply both sides by 10 pi, or 2 pi times 5 basically, and we can reduce those. And then we have 10 pi here times 105 divided by 160, because there's no more degrees, so the arc length is equal to 35 over 12 pi, or 9.16 meters. Okay, I prefer this answer in this class. Okay, on your test it will have the pi in it. I don't want to multiply it out, because once you multiply it out with 3.14, you've rounded the answer. It's always better to have the exact answer whenever possible. Okay, here's another one. Find the arc length given the radius and the central angle. Now notice this time there's no degree symbol. If there's no degree symbol, what does that tell you? That this is actually in radians. Okay, so we're going to find s by substituting r and theta into this formula, and we get this, and we can go ahead and multiply by 24 and cancel the 2 pi's. So s is equal to 6 pi over 5 times 24, which is 144 pi over 5 inches. And this is the answer. Put in your calculator, dividing and multiplying by pi, but this would be the better answer, especially if you're going on into higher math, calculus and so on. We don't write answers like this. Okay? This is more of a practical answer if you were an engineer or writing this out as a to give to a consumer, like you put on a packaging. You would say, if you knew the weight, how many ounces are in a bag of Cheerios, you would use this number, and because this is too confusing to people that are not good with math. This is your email question number 2. Find the angle in degrees and in radians. So we're trying to find this angle here. This is theta. And you are given that the radius is 7 and the arc length around here is 32 centimeters. Okay, moving on. Here's another example. This is a lawn roller. It's when you're installing a lawn and you're putting down seed and then you're putting dirt over it. You want it nice and level. So we have this kind of a barrel looking thing, and it's usually made of metal or maybe plastic, and they fill it with water so it becomes very heavy, and they drag it with a tractor, or maybe you can drag it around on your lawn, but because it's heavy and rolls around, it flattens the lawn and makes it nice and even. Okay, so this is a lawn roller, and the radius of the lawn roller is 10 inches, and it makes 1.5 turns or revolutions per second. Find the angular speed of the roller in radians per second. Find the speed of the tractor that is pulling the roller in inches per second. So if you understand the problem, this one's an angular speed and this one's a linear speed because it told you it's in inches per second. By the way, a tractor pulls linearly, right? The tractor is not going to go around this roller. It's going to pull it flat. So we're given 1.2 revolutions per second, and the diameter is equal to 20 inches. Okay, this is the radius, and the radius is half of the diameter. So 2 times the radius gives you the diameter. So we're trying to find radians per second. We know that the relationship of radians to revolutions is 2 pi radians is equal to 1 revolution. 1.2 revolutions per second times 2 pi radians per revolution, cancel, and we end up with 2.4 pi radians per second. Alright, so part B, find the speed of the tractor that is pulling the roller in inches per second. So we're going to write down our given, and then we want this in inches per second. So we take our revolutions per second times 20 pi inches. That's right. And then we get 24 pi inches per second, or 123.2 inches per second. Okay, that's it.